you want some reinforcement and some review for your quiz tomorrow on 5.3, just do the first half of your 5 goals.
Question.
Yep.
Is there like a no calculator part on our test then, so we're not?
Good question. So,
Because I mean, I do it either way, but one way is easier for me.
yeah, most of your points, if I do allow calculators, most of your points will be
Showing your work.
your antiderivative.
Whoa, whoa,
Okay.
whoa, no calculators?
You'd be able to use your calculator, but you have to do it the
Oh.
antiderivative way.
And if you're evaluating like
Okay.
a polynomial even,
Okay, well that'd be easier to find the antiderivative too.
yeah, the antiderivative isn't that big
It's-
of an issue. The issue would be if I didn't allow your calculator, like the arithmetic manipulation of that, right? You'd have to do 1/4, 4 to the 4th, and even if I give you a dumb calculator, sometimes the dumb calculators are tough to work with because of the order of operation.
They're too dumb.
Well, that's why you just do things one at a time when you get a dumb calculator.
Yeah.
That's how I
Yeah,
do
but
it.
that's.
So that's why, like if you get here, that's sufficient work if you just write the answer at this point. So you just type that into your like the arithmetic, and then just write the answer.
I would just like do the things that I don't know how to do in my head, like 4 to the 4th, and then I would just go from there and do it in my head.
Okay.
Or
Don't introverse him to get rid of focus. No, I'm scared.
well, I'm the one who depends on his calculator all the time.
Yeah, so stop doing that.
And it is important to know how to do this stuff on your calculator, on the
I can.
on the AP exam. It's expected that you will do integrals and derivatives on the calculator. Like they'll give you a huge, like if t sine t minus t cubed plus 10 to the third or something like that. Let's take the square root of the whole thing too. So if this is the rate in which water is flowing into a tank,
Jeez.
Oh,
That's a pretty.
triangular trough.
That you have to then make a stand
Okay.
for.
If the question said how much water is put into the tank the first 30 seconds or 30 minutes, well then you would just integrate r of t from 0 to 30. That will give you, if you're integrating the rate, that gives you the amount. So that would be your answer the first 30 minutes, right? That would not be an expectation that you did that by hand right there. You would just type in
Good.
all of that. And they expect that. If you do it by hand, and it might be possible to be done by hand, it will take you too long and you won't finish the test.
Oh boy, 5 4s on 3 day.
Is it?
Yeah.
Alright, so we're gonna do a quiz on 5.3 tomorrow. We've got a world famous Winkler activity on Thursday. We still have not done the designated deriving. That
Driving.
we've tried like,
Driving.
see what I did there?
Driving.
Oh,
Driving.
So that was an activity we've tried twice and
Doesn't
failed.
mean driver.
So I don't
One of
know
us could just waste
when
it.
and if we will do the designated driving activity. Thursday's activity really doesn't have a fun name, but of course it's fun.
And we invite Glenn.
Alright, so fundamental theorem calculus has 2 parts. This is part 2. Part 1 is one when you are finding the derivative of an integral. Alright, so let's do once you find that. Sorry for the 20-minute delay here. So antiderivative of sine.
Yes, I know it.
Evaluate at x, so it's sine of x minus the sine of 3, right?
Oh my goodness.
We're done,
oh.
right? Okay, let's find the derivative of our outcome. So now find the derivative.
Negative cosine? Wait.
Oh dear.
I have no idea.
I thought the derivative was that.
Why is it?
Oh, well
Oh,
that's,
cool.
You're not taking the
that's
derivative of
easy, I
cosine
think.
from the anti-
It is.
which- and
Okay, derivative of sine
is cosine, that's right.
is cosine
Oh,
x.
wait.
The derivative of a constant is 0. Okay, so on your assignment or
wait, that's the original.
on the test or on the AP exam or on a quiz, you will be asked to do this. Y equals integral of 3 to x cosine of t dt, and it'll say find like dy dx. So we're finding the derivative of an integral. So you could integrate it and then differentiate, but integrals and derivatives are inverse operations. So you could just take that x and drop it in. Okay? So that works as long as there is a constant on the bottom. So if it was pi right there, what would your answer be?
Cosine x.
If it was 100 right there, our answer would be
Cosine of
cosine x. So as long as that is a constant down there and just x up there, you can simply drop it in. Now this is one of the easier concepts you will learn all year. Drop it in, right? That's not hard. Students get this wrong all the time, and I tell students every year, you will get this wrong because you forget what you're doing. We are finding the derivative of an integral. Okay, and they aren't always this easy, but ultimately you're just dropping it in.
It's like log to the 10 to the x.
So if you have,
Inspired.
if I have, and it does get a little more complicated, if this is 10 and this is 4x cubed, and let's say this is the square root of t dt,
Fork.
we can drop it in. So it's the square root of 4x cubed. Notice there's no dt or dx or anything like that. No plus c or anything like that. We just drop it in. But then you have to multiply by the derivative of that because of the chain rule. So we'd be multiplying by 12x squared. And I suppose we could clean that up, combine the x's.
No,
Might as well.
leave it,
So
leave
that's
it.
24 x to the, that's 3 halves plus 2 would be
5.
7 halves.
But it's,
I can't do it. Just right there.
Oh man, I was gonna say 5.
what do you mean?
Yeah, you're
7 halves?
Wait.
So that would be your best.
Yes, it's 7 halves.
You just
Okay, so if it's not just x, it's 4x cubed, you just have to multiply by the derivative of that. I have more examples. Yeah.
Okay, so it says right here that this is only true if f is continuous on a to b, but it doesn't have a b. What's b?
B is the.
I don't.
So it has to be continuous then.
Okay, more examples.
So if the x is on the bottom, you would just flip it and make it negative.
Nice.
Oh no.
Oops.
They're just told us how to do this one.
Oh, it is.
I cannot believe myself.
Alright, so x is on the bottom, we can flip it. That's one of our properties we learned yesterday. So it's from 2 to x of t squared plus 6 dt. But now we have to negate it, right? And we are finding the derivative, so we can drop it in, so it's negative x squared plus 6, and we're done.
I did it.
that's pretty.
Alright,
That's pretty.
what if we have,
You can tell that it's not because of the way it is. Oh no.
No, no, no.
Now you divide the 3.
and we're finding the derivatives.
Can you pull out?
So that's a lot of the work where we're gonna get things everything's wrong. We are finding the derivative of an integral. You're asked to find the derivative of an integral. We apply fundamental theorem part 1. So we have two of them. They both have variables. We drop in the x squared, so it's cosine of x squared. Any idea what you would do with the 3x?
Divide the x.
Minus
Minus.
cosine of 3.
Oh, we forgot to multiply by 2x here, right?
Yeah, I was gonna say.
Thank you. And now minus, drop in the 3x. So it's
Times
cosine of 3x times 3. That's your answer. There's no dx, there's no plus c or anything, it's just, it's an expression in terms of x. Alright. Don't know if there's any other examples that are different than what I have up here. Do you understand?
Yes.
Let's see. There might be a story problem or something at the end of 5-4 I wanted to look at.
Their real life applications aid was very beneficial for me.
So I'm not gonna go through it, but look on page 284. So page 284, example 7, it says find in the area using, is nint, that's obsolete, isn't it? What does your calculator say? Is it function? Fnint?
Yeah.
What's obsolete?
What? It's a dinosaur.
FNINT.
Okay.
Okay, so if we're trying to find the area of a region, and this would be total area, all areas positive, you could just find the absolute value of your function and then integrate it.
How do you hit an absolute value?
How would you do it? It's on your calculator. Do you want how to? It's that big calculator. So if you want to find total area over an interval, just integrate the absolute value of the function, and it'll make it all positive. Does that make sense? You probably would have.
So do you want to like write that down so we can visually see what that means?
Oh, wow.
Do you want an
So
example?
like you would put in absolute value and then do the int.
Yeah. So let's say find area. This is total area of sine x from 0 to 2 pi.
So
We're looking for that area plus that area.
well you would just have
If
to
it
know-
wasn't as straightforward, we would integrate absolute value of sine x
from 0 to pi.
from 0 to 2 pi. You run it, so see if you can do that on your, wasn't this 2?
Yeah, so then it would just
So
be
we should
4.
get 4, so see if you get 4 on your calculator using the absolute value.
I just meant we'll calculate.
Does Jake still have it?
Yeah.
Why?
I haven't asked for that. I'm gonna see if I can put Creed's equation in, but screw it around my test.
We found out that mine is backward.
Okay.
Like, well, I think that's for answers to L and R.
So what do you do if like your calculator breaks in the middle of the exam?
You cry.
Beg for mercy.
Grab your backup.
Let me
How many
bring
backups are you
$100
on?
Yes, my $120 backup.
A lot of people bring 2.
Who can afford that? Angel's already borrowing 1.
Yeah, I don't even have one. How am I supposed to get 2?
Borrow another one from her back.
I don't think you're supposed to take more than
Well,
one.
ask. I'm sure Andrew would be fine.
I wonder if they, I think they allow you to bring 2.
I think it's 2. I don't think you bring 3 back.
Alright, that didn't work.
Wait, what did you get?
Whatever I did.
Are you in radian?
I
You do get 4?
Yeah.
Okay.
He sure did what he did. No, I don't know how to type stuff in.
Alright.
0 to 2 pi.
Wait, I gotta finish it.
Because when
What's
you
the difference?
when you flip it, it becomes
What
like
he says.
Alright, last thing in the book, example 8, determining cost from marginal cost. Do you remember what marginal cost means?
Cost is
Your profit, your break-even point,
no.
all.
It's kind of the cost of producing one more unit.
What's marginal in calculus mean?
Yeah.
Oh,
This part,
like more, it's not
part
additional.
this part of the paper.
No,
Learned it in economics, that's what it means in economics.
I bet it, yeah, because margin, yeah, right.
Like how much more it would cost you to
Is
do.
it just the derivative of the?
Derivative, thank you.
Dang it,
Did you
Cal.
really? I was still laughing at margin, butter.
It's like, yes,
Okay, so if you see marginal profit, marginal cost, that means the derivative. So we have determining the cost from the marginal cost, so you're determining the cost from the derivative of the cost, so we have to integrate it. It says the fixed cost of starting manufacturing run and producing the first 10 units is $200. So no matter what, our first 10 units is $200. We're not going to do any calculus to figure out the cost for the first 10 units. It's given to us, it is $200. After that, the marginal cost becomes the differential equation 1,000 over x squared. So we want to find the total cost of producing the first 100 units. We already know the cost of the first 10 units, so we're trying to find the cost of the next 90 units. So you would have to integrate from 10 to 100. Does that make sense? We don't do 0 to 10 because we already know that is 200. So it's, the total cost is 200 plus the integral of the marginal cost from 10 to 100, and that'll give you your answer. Looks like it's 90 additional dollars. So 290 total. Make sense? Yeah.
Why are those in that picture below? Why are these like eating a bunch of cupcakes?
Maintaining a steady inventory to ship to the wholesale.
It's from a
We've got
I
I
Love
Love
Lucy.
Lucy on the right.
yeah. And then Ethel, her friend.
Danger, be careful when belt is in motion.
They're eating
They're
them.
wrapping candy in the episode.
So apparently there's an excess. There's too many cupcakes, and they're moving by, and they're trying to maintain, so they're eating them.
Yeah, they're trying to wrap the candies and they're not keeping up, so
Oh.
they have to start shoving
I
it
think
in
they
their
have a
mouths.
gig of like
Any I Love Lucy fans in here?
It's pretty good. I've seen it when my mom like, had that on all the time.
She's actually pretty funny, huh? I mean, she's black and white, which means she's even older than me, but she was kind of funny.
No, I really want sushi, like what the heck?
Okay, so the stuff we just learned today looks like it starts kind of number 37 in your 5-4 cent. But the first page, I bet you the first page on page 286, most of that would apply to your 5.3 quiz tomorrow. Questions before I let you work?
Coach, what was it?
Great. So quiz tomorrow, another day on 5-4. Thursday is an activity that will take all hour.
So many activities.
And then we'll start 5-5 on Friday
So many activities.
with a little bit of time to finish up your activity.
Wait.
So
that
when's
means
the
after
next
the
quiz?
quiz we have to learn more by 4.
So after Wednesday, your next quiz is next Tuesday on 5-4 and 5-5.
Tuesday, 5, 4, 5, 5.
How'd you say that so quickly?
Tuesday, 4, 5, 5.
Test next Thursday is the plan. I have a meeting all day on Wednesday. Doesn't that work out nice?
Oh, wow.
I love when you do that.
I'm thinking about calling in sick to my meeting all day. Is that- I just got filmed saying that.
Conley leaves meetings to come to class constantly. If we were doing a lab and he's like, I don't think I need to go. I'm just like, come to the lab.
Well, my first 4 hours of the day on Thursday are all quizzing and testing.
Yeah.
And I don't want to be gone the day before.
Why do you guys have to go to one duty yesterday?
Oh, apparently there was a CPR training for the administration.
We need
So
more
they all
essential
were in a
questions.
meeting, they pulled in some
We
teachers.
need more of not
I know.
giving them help.
Oh, we're good with the actual lesson now.
Yeah, we're done.